Alright, today we are starting Unit 6, which means we're going to need a new tab. So we're going to go ahead and cut the extra off. We got to a new unit pretty quick this time, I know. So Unit 6, so in your notebook you're going to go ahead and turn it to page 82 and 83. So page 82 will be blank. It'll just say Unit 6 on it. 83 is where we're going to glue that tab, and remember it's going to stick out just a little bit. So it's actually a tab, and then we're going to talk about the first lesson in this unit. So go ahead and glue that in. Okay, and this one is a little different actually. I should have made the blocks that way, but I didn't. We will talk about exponent rules and the integer exponents both today. Exponent rules is going to be on 84 and 84 only. Okay, and integer exponents is going to be on 85 and 85 only. And those are the two that we're going to be talking about for this video and the next video. So let's go ahead and label these pages. Turn to page 84, it's the next page over. And we're going to label it 14.0, exponent rules. Okay, and we're going to go ahead and glue that foldable in. It says exponent rules. It's blank. We'll come back and work on it. We're not going to do it all today. We will do 2 of them in this video, and then we will come back to this each time, okay? So we'll come back to that. We're only going to do 2 of them today, the bottom 2. You'll see that in just a second in the video. All right, once you do that, we're going to go ahead and label page 85 as well. And page 85 is going to be 14.1, integer exponents. And that's where we're going to glue in the other foldable that we won't completely finish today. Okay, so we'll glue that one in here. And I'm going to go ahead and glue it in actually. So this one that says integer exponents is going to be glued in right here on page 85. And then follow the video. We won't finish it today, okay, but we will come back to page 85 to finish this one out. All right, so let's go ahead and glue it in. We'll finish it in the next video. Okay, here we go. Let's get started on the exponent rules now. We're going to start with integer exponents. You have this sheet, or should. This sheet covers all of the exponent rules. We are only going to talk about a few of them today. We're going to talk about the bottom 2. I'll pull this out every time to talk about the new ones that we are learning, but specifically we're going to start talking about integer exponents, which is the last 2 specifically. So when we have this a is an integer, when we have any value number with a negative in front, so a negative exponent, to change that, we are always going to put it over a 1 in a fraction bar. I obviously need a new pen. So we have 1 over x to the a, which is that number. Notice it is not negative anymore, but the rule is that if we have a negative exponent, we put it on the bottom of a fraction, which will change it to a positive, and we put 1 on top. The next one is 0 exponents. Anything raised to the 0 power is 1. These are the 2 rules we're going to focus on today. We're going to look at some examples with that on this next foldable. So this we will come back to throughout. Let's look at the next foldable, which is integer exponents practice. Alright, so we've got numbers 1 and 2, 3 and 4, all of them dealing with a negative exponent, which based on the rule, that means we are going to write a 1 over 5 to the 3rd power. Now we can simplify that if we would like to. To continue simplifying it, we would have 1 over whatever 5 to the 3rd power is. So 5 times 5 is 25, times 5 again is 125. So our final simplification would be 1 over 125. Same with number 2. I have a negative exponent, so I'm going to have a fraction bar. I've got 1 and 2 to the 6th power. And 2 to the 6th power is 64. So my solution is 1 over 64. Not necessarily solution, I'm not solving anything, I'm just simplifying as it states here. Alright, notice, and this becomes very important, that my parentheses are around the negatives inside those parentheses. That means when I actually move it, I leave it like that. I have a parentheses negative 5 squared. The reason why I leave the negative 5 in those parentheses is because then I have negative 5 times negative 5, which is 25, positive 25. There's my simplification there. It is a little different with this one. The negative is still going to stay in front of the 4, but it's going to stay outside of the parentheses. So 1 over negative 4 to the 3rd equals 1 over, here is how these with negative outside works. You have 4 to the 3rd power. So 4 times 4 times 4 again. 4 times 4 is 16. And then times 4 again is 64. So I have 1 over 64. The negative in front, though, lets me know that the entire thing is just going to be negative because it is in front. Okay. Likewise with this one, if there's just a negative in front, there's no negative inside parentheses like there was here, my final answer is going to be negative. I don't know what yet, but it's going to be a negative. Anything raised to the 0 power is 1. So my solution for number 5 is negative 1. And number 6. If you're doing these by yourself, you should pause them between some. Make sure you can get the correct answer. Number 7 is one of those especially. It is worked just like 3, 5, not 5, 3, 4, 2, 1. They're all the same, except for number 5. So I have 1 over 7 squared. I'm just going to leave parentheses wherever they show me to them. I really didn't even need the parentheses there. It wasn't going to change the answer. But 1 over 49. This is simplifying with numbers. So I'm going to simplify as much as possible. I'm now going to do some without numbers, with just variables. I actually will be, as the directions say, evaluating each expression. So 7 through 12 is talking about evaluating, meaning I'm going to plug the number in. I am going to go ahead and plug the number in at the end, after I have simplified and gotten rid of my negative exponents. So I have d to the negative 3rd. So if I'm simplifying d to the negative 3rd power, I'm going to have 1 over d to the 3rd power. It's no different than what we did on the front, except we now have a variable. I'm then, because I am evaluating, going to plug in negative 2. So 1 over, I'm going to put it in parentheses when I plug it in. Now that I've plugged it in, I'm going to determine negative 2 to the 3rd. Negative 2 times negative 2 times negative 2. That will give me negative 8. So negative 1 over 8 or 1 over negative 8. And it's the same. No matter where the negative is, the final solution is negative. Alright, now I'm going to bring down this a to the 5th, b to the negative 6th. This one is a little different. I'm looking specifically at what is a negative exponent. What has a negative exponent? B to the negative 6 is the only thing with the negative exponent. So when I move it, that's all that's going to move. A to the 5th is not a negative exponent, so it is going to stay in the numerator. B to the 6th becomes positive only by moving it to the denominator. I'm then going to plug in a 3 for A and a 2 for B. I'm then going to plug that in my calculator to simplify it. I'm going to go ahead and just do it all at once in a fraction. So 3 to the 5th, 2 to the 6th. That does give me a rather large fraction, 243 over 64. The calculator would reduce it for me, which means this is simplest form, and I do want you to leave it as an improper fraction. So 243 over 64. Just like a few minutes ago, if you're working on these while watching the video, it's a good idea to pause it, kind of look at some of these, make sure you can get the answers without me. Number 9, notice the parentheses around the whole thing, b minus 4. That means in order to have a positive exponent, which is our end goal, we never want a negative exponent, we are going to move the entire piece, b minus 4 squared. Whatever the negative exponent is attached to is what you have to move. I'm then going to plug in a 1 for b. That is 1 over 1 minus 4 is negative 3 squared. That becomes 1 over 9. 1 over 9. You could have done what we did up here, where you plug it straight in the calculator at this step right here. You can choose that. Okay, similarly, number 10, I've got 5z to the negative x power. This is very similar to number 8. Each of these pieces is separate. There's like little multiplication between them. There was a multiplication between this. I have to decide each piece whether that is got a negative exponent directly correlated to it or not. 5 does not have any exponent, so it is going to stay in the numerator. Z has a negative exponent of x, so I'm going to move z to the denominator and make the x positive. I'm now going to plug in z and x. 5 stays the same. Z is negative 3. X is 2. 5 over negative 3 squared is 9. Again, leave them as fractions. It's easier to worry about. You don't have to worry about how much you have to round it or anything like that. Okay. Again, good idea to pause it. See if you can try these on your own. Number 11. Since this is in parentheses, see, these are the exact same problem almost, except this is in parentheses. Having it in parentheses means we don't have the negative exponent only with z. We now have it with the entire piece here, which means when we move it, we have to move the entire expression there, the entire piece. So I have a 1 in the numerator and 5z in parentheses, because it's in parentheses, to the x in the denominator. Then plug in z is negative 3, double parentheses there, raised to the second power. Again, I could plug it straight in my calculator if I wanted to. 1 over negative 3 times 5 is negative 15 squared. And that solution is 1 over 225. 1 over 225. Last but not least, for the evaluating section is number 12. I'm looking at each piece. Let me go ahead and write it down. It helps me out. So each piece. I'm going to go ahead and draw my fraction bar. That's a good first step. Negative 3 is directly tied to c. That means it needs to change positions. Negative 2 is directly tied to 16, so it needs to change positions. Nothing needed to stay in the numerator, so we are going to place a 1 up there. I'm now going to plug in 4. 4 to the third and 16 squared. All this is multiplying everything. which is, like I said, you can figure it out without a calculator. Calculators do make it easier, but so alpha y equals 1 over 4 to the third power times 16, and I'm putting in just like it shows. I didn't change anything. You've got this 6.103515625e to the negative 5. Here's why you have that. This is telling you that this decimal is that scientific notation, by the way. This decimal is so large that they're not going to write it in a fraction of any type. That if I wrote it down as a decimal, I'm just doing this as an example, we're not actually going to do any decimals, I would take that value and move it to the left 5 places. 1, 2, 3, 4, 5. So it would be 4 zeros, decimal, 40610. I'm going to leave the answer like this if I get a solution in scientific notation.